Hello guys, ang topic natin ngayon ay determining the center of mass. And dito sa ating lecture, yung computation ng weights, yan ay yung mass, which includes the roof beams, the interior trusses, tapos yung firewall, tsaka yung kalahati ng columns from the roof beams going down. Okay, so with regards to roof beams, mag-start tayo dito sa roof beams at grid A. So dapat alam natin yung weight. And beam at grid A, that is R1, which is 25 by 30 centimeters. Okay, so the weight is 0.25 times 0.3 times the length na 13.5. So we have the volume, and then multiply that by 23.5616, the unit weight, para meron kang kilonewton. And then eto, x and y, eto yung centroid nung beam at grid A. Okay, take note that the beam at grid A, iisang section lang yan, kaya buong beam na yan, which is 4.5 times 3. So ang centroid niyan from the origin, let's say ang origin nandito, would be 6.75, or that is 13.5 divided by 2. Tapos yung y naman would be 7 plus 2.5, or that is 9.5. And then dito naman tayo sa beams at grid B. Notice the beams at grid A, B, and C are all the same, which is R1, and they are all 13.5 meters. So pare-parehas lang yan ng weight. Sa grid B naman, ang kanyang centroid would be 6.75, pero ang y from the origin, let's say this is the origin, is now 2.5. And then beams at grid C, the x coordinate of its centroid is 6.75, pero ang y dimension niya, or y coordinate, is 0. And then Wx would be the weight times the lever arm X. Tapos Wy would be the weight times the lever arm Y. And then we can copy this. Ayan. Now let's go to beams at grid 1. Also, ito ay R1 pareho. Tapos at grid 2, R1 din, grid 3, R1, grid 4, R1. Ngayon, ang R1, that is 25 by 30, ang pinagkaiba lang yan, yung length, instead na 13.5, it is now 9.5. So we have 16.7876. Tapos, ang x-coordinate niya would be 0. Ang y-coordinate niya would be 9.5 divided by 2. And then, beams at grid 2, parehas lang yan ng beams at grid 1. Ganon din sa grid 3 tsaka grid 4. Pero nag-iba ang kanilang mga centroid. At grid 2, ang x niya ay 4.5. And then, ang y niya is the same, 4.75. And then at grid 3, ang x niya would be 4.5 times 2, or that is 9. Ang x niya ay 4.75. And then at grid 4, ang x niya is 13.5. And then 4.75 din. Now let's check the weight of all the beams. Okay, so isam natin yan. Dapat parehas sila dito sa weight ng roof beams. Okay, so parehas sila. So that means tama yung ating ginagawa. And then we can now compute the WX and WY. Now let's go to interior trusses. So we have trusses at grid A. Sa grid A, we have 1, 2, 3, 4, 5 interior trusses, tsaka 2 exterior trusses. Okay? So, trusses at grid A, that would be 5 times the reaction ng interior plus 2 times the exterior truss reaction at grid A. Okay, tapos ang kanyang X would be obviously 6.75, or that is 13.5 divided by 2. So, inassume natin na ang centroid nung pitong reactions would be at this point. Okay, sa gitna. Or that is between point 2 and 3, or grid 2 and 3. And then Y would be 9 point, that would be 7 plus 2.5. Okay, beams at grid A, correct ko lang ito. This should be 9.5. Next, trusses at grid B would be 5 times interior truss at B, which is 11.298. And then the X coordinate would be 6.75 again. Pero ang Y niya is now 2.5. And then at grid C, okay, balik tayo sa grid B, 5 times the interior truss reaction plus 2 times the exterior truss reaction at grid B. Ayan. And then at grid C, we have 5 times interior truss reaction at C plus 2 times the exterior truss reaction at grid C. Ayan. Still, it is 6.75, pero ang Y niya ngayon ay 0. Now, let's check the sum. Dapat parehas sila, no? 179.294. Okay, so we're good to go. Now we compute the W times X and WY. Now let's compute the firewall. So yung firewall naman, it is composed of two areas, yung triangle tsaka yung rectangle. Parehas lang nito yung nasa load computation ng STAAD. Let me show you. So ito siya. Roof loads, ayan, firewall loads. So sa 2.5 meter firewall, yung height niya ay 0.9, no? Tapos dun sa dulo naman ng 7 meter, it is also 0.9. Okay? Tapos yung highest part of the firewall is 2.5 meters. Okay? So let's solve that. Ayan, 0.9. Ngayon, itong 1.6 that is taken as the highest, which is 2.5 minus 0.9. Yan yung 1.6. And then yung length would be 9.5 meters. Tapos, this is 1 inch, or this is 4 inches CHB with one face plastered. Okay, so let's That is 2.5 plus 0.24. Okay? Now, let's compute the area. Sa rectangle naman, this is simply 9.5 times 0.9. Okay? Ito naman, 1/2 base height. Yan. So, 9.5 times 1.6 divided by 2. And then, we multiply the area by 2.74. Okay? And you multiply it by the number of units, which is 2. Ito, dalawa sila kasi kabilaan yan eh. Okay, so let's check. 8.55 times 2.74 times 2 units. Okay, tapos 41 din yan. And then its total is 88.502. So yung firewall, take note na since parehas sila na rectangle tsaka triangle on both ends, ang kanilang centroid would obviously be at the center of the structure. Okay, so we simply take here 88.502. Yan. So 88.502. Tapos yung x coordinate niya would be 6.75 tsaka 9.5 divided by 2. Now let's compute the third floor square columns. Kalahati lang ang sasolve natin, ano? Take note, ito yung R7, ito yung third floor columns. Kalahati lang yan. So that is 3.2 divided by 2. Okay? Which give you 1.6. And then, notice na lahat ng columns ay R7 sa third floor, 0.25 by 0.25. So, the volume here would be 0.25 times 0.25 times 1.6. Tapos, yung weight niya would be the total volume times 23.5616. And we have here 12 units. So, at grid 1, you have 3, 2, 3, grade 3, tatlo, grade 4, tatlo. All in all, you have 12 units. So, the weight would be the volume times 12 times 23.5616. And that is 28.2739. Okay, but be careful. Ang distribution nito ay or ang centroid nitong 12 columns ay hindi sa gitna, no? So, kunin na lang natin yung nasa grid A as 1. So, that is simply 0.25 times 0.25 times 1.6. Yan yung volume. Okay, times 4 units times 23.5616. Okay, so that is 9.42. Ang x coordinate or yung centroid ng apat na columns na yun, nandito sa gitna. So, we have here 6.75, tapos yung y niya would be 9.5. Next, at grid B, parehas lang yan, 9.42. Grid C, 9.42 din. So, let's check the sum of these three, which is your columns at A, B, and C. So, we have 28.27. O, yan, parehas na sila. At grid B, the x-coordinate is 6.75, pero ang y niya ay 2.5. And then at grid C, x-coordinate of that is 6.75, pero ang y niya would be 0. Okay? And then, copy natin itong wx tsaka wy. Paste natin dito. Now, let's check the sum of all these weights. Dapat parehas sila dito sa 434.789. So, sum. Yan. So, parehas sila. So, meaning, pwede natin ngayong solvein yung center of mass dito sa roof level. So, let's compute the x-coordinate of the center of mass. To do that, you have to total the W sub x. So, sum of this. Ganon din sa sum ng W sub y. So, for x sub g, that is the summation W sub x divided by summation weight para maiwan yung x-coordinate ng total weight. So, that is 6.75. And then, yung y-coordinate ng center of mass or center of gravity, that is equal to the summation of W sub y divided by the total weight. Yan. And then, si STAAD naman, take note, yung kanyang reference, ang origin niya nandito sa upper left. Okay? Pero, sa sample natin dito, ang origin natin nasa lower left. Okay? Yung figure dito sa ating sample, nasa positive x-axis tsaka positive y-axis. Pero kay STAAD, ang kanyang figure nasa negative y-axis. Kaya, para kay STAAD, instead of 4.57, ima-minus natin sa 9.5. Or that is the y length of the building. So that is 9.5 minus 4.57. Now let's compare this center of mass with STAAD. While waiting, dito na tayo sa, tuloy natin dito sa third floor. Okay, so bumalik na si STAAD. Command analysis output. By the way, dito sa STAAD, sa sample ko, I think kasali na yung, let me check. So, ito yung truss reactions. Ayan, sa gitna ng beam. And then, ayan yung exterior trusses. Kasali pala. Tsaka yung firewall loads. Ayan siya. Okay, so let's go to utilities and then analysis output to check the center of mass. Dito tayo sa floor diaphragm. Ayan siya. So, ito siya. At number 4, or this is level number 4, the height from the support is 11.1 meters. So, floor weight 434.76. So, we can compare that with our Excel. Ayan, 434.789. So, konti lang ang diferensya. And then, yung center of mass, X sub G, is 6.75. So, parehas tayo, no? Tapos, yung center of mass, yung z-coordinate niya, is 4.936. Ito yun. Take note na kay STAAD, yung direction ng y niya would be vertical. Okay, so dito naman sa ating sample, yung y coordinate niya is the yan. So 4.922. So almost similar sila. Okay? Sa computation natin 4.57793, pero kay STAAD i-minus mo yung ito 4.57 sa 9.5 and you will get this. So konti lang ang difference. So I'm just showing you na malapit ang ating manual calculation kay STAAD. Now let's solve the third level. Okay, so dito kay third level, parehas sila ng procedure. Magkakaiba lang siguro sa mga dimensions ng beams. Meron tayong columns sa ilalim ng beams, which is ito sa ilalim, and yung beams, ayan, at meron ka ulit columns sa ibabaw, which happens to be kalahati ito nung third floor columns. And then at third floor beams, remember na meron na tayong dito na tayo, no? Meron na siyang walls. Ang i-consider nating wall dito would be full height, or that is 2.9 meters. Okay, tapos yung height naman ng columns, kalahati nitong third floor columns, saka kalahati ng second floor columns. Okay, kalahati is mid height, or that is 3.2 divided by 2. So let's start with the third floor columns, kalahati lang. So at grid A, okay, at grid A dito, nagkataon na ang mga columns natin ay pare-parehas. Pare-parehas silang R7 sa third floor, sa second floor, pare-parehas silang R8. Now, yung third floor columns, that is 0.25 by 0.25. Okay, so let's compute the weight. So at grid A, you have 0.25 times 0.25, that's the area, multiplied by 1.6, that is now the volume. And then you multiply it by how many pieces? 4. At grid A, you have 1, 2, 3, 4. Then you multiply it by the unit weight of concrete, 23.5616. And then, ganyan din sa grid B and grid C. So, pwede nating copy yan. Now, the centroid of the columns at grid A, you have 6.25. And then Y is 9.5. At grid B, dito na sa grid B, X is 6.25 again, but Y is 2.5. At grid C, X is 6.25, but Y is 0. Now let's check the sum. So 28.2739. So correct. Now let's go to beams at grid A. At grid B, pare-parehas din silang R3. So pare-parehas sila si grid A, grid B, tsaka si grid C, which is 0.4 by 0.35. Okay, so 0.35 times 0.4, that is the area, multiplied by 13.5, that is the length, multiplied by 23.5616, and that is the weight of the beam at grid A. Next is the x coordinate, again that is 6.25, the y is 9.5. And then we have beam at grid B. So parehas din silang R3, so we can copy that. Same with grid C. So magkakaiba lang sila ng centroid. So 6.25, this time this is 2.5. And then 6.25 again, but your y coordinate for the beam at grid C would be 0. And then dito na tayo ngayon. So natapos na natin yung longitudinal beams. But meron pa tayong beam at grid A prime, which is R12 with a dimension of 0.28 by 0.4. So the weight is 0.28 by 0.4 times the length, which is 4.5, multiplied by 23.5616. And then the x coordinate would be half of 4.5. Tapos yung y coordinate would be 2.5 plus 4 meters. Remember this, ano? So that is 6.5. Now, dito na tayo sa transverse beams, okay? Notice na si R30 beam at grid 1 si beam at grid 1 is R13, at grid 4 R13 din siya, pero ang length niya ay 7 meters. So pwede nating pag-isahin na yan. Kaya beams at grid 1 and 4. Now the sectional area for R13 is 0.38 by 0.42. So 0.38 by 0.42 times 7 meters. Yan yung length. Multiplied by 23.5616. And we have 2 units. Ang x coordinate niya would be, syempre, nasa gitna. So that is 6.25. Pero ang y niya, syempre, nasa gitna nung 7 meters. Plus 2.5. So that is 3.5 plus 2.5. Which will give us 6. Now, dito na tayo sa beams at grid 2 and 3. Notice na parehas silang R14. Okay, so the dimension of R14 is 38 by 48. 0.38 times 0.48 times 7 meters times 2 units times 23.5616. The x coordinate again is 6.25, and then the y coordinate is again 6. Okay, now notice na dito sa at 2.5 meter, this is hallway, pare-parehas silang R3, pare-parehas silang 2.5. So we just take the volume of 1 unit multiplied by 4. So that is R3, which is 0.35.4 times the length na 2.5 multiplied by 23.5616 multiplied by 4 units. And then ang x coordinate niya again is 6.25, but the y coordinate is 0. Okay, and then meron pang kulang, beam at grid 1 prime. Ito, oh sorry, this is not 0, this is 2.5 divided by 2. Okay, nasa gitna ng 2.5 yan. at grid 1 prime, this is, the volume is R2, which is 0.25 by 0.3, multiplied by the length na 4 meters times the density of concrete, 23.5616. Now the x-coordinate is 2.25, and then the y-coordinate is 2.5 plus half of 4, which will give us 4.5. Now let's check the weight of all the beams. So 298.337, parehas sila. Okay, so that means our weight is okay. Next, we now compute for the columns. So notice na yung columns dito sa taas ng third floor tsaka yung columns sa baba ng third floor, parehas lang ang location pero magkaiba ang kanilang dimension. So we can just copy this. Pero iba na ang kanyang dimension. It is now 0.4 by 0.4. Okay? So palitan natin yan. Magiging 0.4 this will now be 0.4 times 0.4 times 1.6 times 4 units times 23.5616. Yeah. Okay, let's check the sum of the weights ng columns sa ilalim is 72.38. Ayan, so parehas sila ulit. Again. Now let's compute for the walls. Okay, medyo challenging na yung walls. So, ito ay 4 inches exterior wall, 4 inches interior wall din. Tapos, ang railing mo, 4 inches din. Pero, iba na ang kanyang height. Naging 1.2 meter na. Okay, so let's compute for the walls. We first start with grid A. Ang technique dito, dapat yung bawat weight mo, alam mo yung kanyang centroid. And that is the X and Y. So yung at grid A, so that is, let's say, 2.98, ano? 2.98 is taken as 2.5 plus 0.24 plus 0.24. And that is 4 inches plastered on both sides. So at grid A, the area of the wall would be 13.5 times 2.98 times 13.5 times 2.9, that is the height, okay, multiplied by 2.98. So that is the wall at grid A. Tapos ang centroid niya would be 6.25 tsaka 9.5. And then markahan na natin yan. Para hindi tayo malito. Okay. Let's say, yan siya. Na-compute na natin siya. Next, we compute for the wall at grid 1 to 4. Which is this. Ngayon, ng isang wall na yan would be the length 7 times the height na 2.9 multiplied by 2.98, and we have 4 units. Oops. Times 4. So that is 1, 2, 3, 4 units. Yan. ang centroid niya would be 6.25 tsaka 2.5 plus 3.5. So that is 6 meters. Next, wall at grid B. Yan na, tricky na ito. Ang wall sa grid B would be, ayan lang, 9 meters lang yan. So that is the length 9 times the height na 2.9 multiplied by 2.98. Ang centroid niya nandito, which is at distance 9 meters tsaka 2.5 meters. Now let's go to wall or railing na tayo ngayon. So tapos na natin yung full height walls. So dito na tayo. Railing at grid C. And that is equal to 13.5 times 1.2. Yan ang height natin. Times 2.98. Ang centroid niya would be 6.25 tsaka 0. Now at grid B, okay, eto lang siya. Yan lang. And the length is 2.25 times 1.2 multiplied by 2.98. And then the x-coordinate would be 2.25 divided by 2. Tapos, the y-coordinate again is 2.5. And then we have the railing at 1 prime, which is this. The length would be 4 times the height na 1.2 times 2.98. Now, the centroid of that would be 2.25 tsaka 2.5 plus 2 meters. Okay? Yan, nandito sa gitna nung 4 meters. And then, last, yung railing dito sa gilid-gilid. Yan. Notice na 2 piraso yan. So, that is 2.5 times 1.2 times 2.98 times 2 units. And then we just copy this, paste it on the other side. Yan. So, kompleto na ang ating wall loads. Ang centroid niyan, syempre, would be nasa gitna, or that is 6.25. The height, or the y-coordinate is 2.5 divided by 2. Now, let's check the weight of the walls. And that includes the railings. 524.927. So, parehas sila. Next is floor tsaka yung stairs. From our structural plans, meron tayong 3 types ng floor. We have the interior flooring, we have the hallway flooring, tsaka yung flooring sa may tapat ng stairs. Okay, so slab number 3, yan yung floors dun sa rooms. The area is 9 times 7 meters multiplied by the load, which is 5.7816. Yang 5.7816 nanggaling yan dito sa staad. Okay? Which is the floor loads. Ayan. 5.7816 yan. Okay. Let's go back. Tapos, yung kanyang centroid would be 9 meters. And then, ang y-coordinate would be 2.5 plus 3.5. And then slab number 4, itong hallway slab, we first multiply the area, and that is 13.5 times 2.5 with the load, which is 4.0736. Yan. And then the centroid would be acting at 13.5 divided by 2, or that is 6. So this is 13.5 divided by 2, 6.75, tapos this is 2.5 divided by 2. Oops. Or 1.25. Okay, nagkamali ako dito. So this should be 6.75. Yan, lahat ng 6.25 pinalitan ko ng 6.75. Okay? Yan. Next would be slab number 4, pero this time dito sa tabi ng stairs. And the area here is 4 times 2.25 multiplied by 4.0736. The centroid is 2.25 plus kalahati ng 2.25. Yeah. And then the y coordinate would be 2.5 plus 2, or that is 4.5. And finally, we have slab number 5. The area is 3 times 4.5 multiplied by the load, area load, or floor load. The centroid is 2.25, nandito sa gitna. Tapos, ang y coordinate niya would be 2.5 plus 4 plus kalahati ng 3 meters. Yan. And then, finally, we have the stair loads. But before doing that, let's check the sum of the floor loads or slab loads. So 606. Okay, so parehas sila. And finally, we have the railing tsaka yung stair slab. Okay. So this is simply equal to 5.96. Concentrated load yan. The lever arm would be, nandito ang application niya, ano? So that is 2.25. Tapos ang y niya, nasa 6.5. And the stair slab, galing yan dito sa 15.8644. And that is the uniform load. So we multiply that with the length na 2.25. Okay. So that is 15.8644 times ito 2.25 times 15.8644. And then ang centroid niyan, syempre nasa 2.25 divided by 2. Tapos ang y coordinate niya would be at 6.5. Okay? So finally, let's check the weight of the stairs, railing plus slab, which will give you 41.65. Ayan, parehas. And then finally, let's check for the weight, overall weight. Dapat parehas sila. Okay, so next, we now compute for the Wx and Wy. So weight times x, tapos dito naman weight times y. Then we copy that, paste it for all weights. Tapos kunin natin yung sum ng weight tsaka yung sum ng Wx tsaka yung sum ng Wy. Okay? Finally, to get the center of mass for xCg, that could be total Wx divided by total weight. And then yCg would be total Wy divided by total weight. For stud, you just subtract 5.06 from 9.5. So ito si stud. Ito yung output. Going to floor diaphragm. Ito siya. So at third floor, the floor weight is 1572.49. Ayan. Malit lang yung difference. Tapos yung x coordinate is 6.844. Malit lang ang difference. Tapos yung y or yung z nya kay stud is at third level, it is 4.433. Ang na-compute natin, ayan. So, almost parehas sila, 4.433. Okay? So, that's it. I'm just showing you na hindi magkalayo ang manual sa software. Now, let's go to second floor level. Dito naman, the same procedure applies. Meron siyang column sa taas ng second floor, beams. Meron siyang column sa ilalim. Ayan, which is composed of half of the first floor columns. Meron din siyang walls. Meron din siyang floors. Meron din siyang stairs. And finally, meron siyang beams. So, ang procedure niya somewhat very similar. And then sa first floor level naman, ganun din. Meron kang beams, meron kang stairs, meron kang column sa taas, meron ka ring column sa ilalim. But this time, ang column mo sa ilalim would be 1.5 divided by 2, which is 0.75. Tapos, yung floor load mo dito sa first floor level, wala na. Dahil ang floor loads mo, ang floor dito, nakapatong siya sa fill. Okay? So, ang loads mo dito, you have the columns, the beams, and then the walls and the stairs only. Now, let's check if they are the same with stud. Sa second floor, ito. At second floor level, or that is at 4.7 meters, ito yun. The floor weight is 1542.188 dito sa ating mano-mano. Kay stud, 1542.21. So, very small lang ang kanilang difference. The center of mass, the x-coordinate is 7.162. So, parehas sila. The z-coordinate, 4.779. Dito naman, sa center of mass ng mano-mano, 4.77871. So, halos parehas sila. Sa first floor naman, the weight is 934.19 kay stud. Sa atin, 934.17. The center of mass, 6.71. Ayan. So, halos parehas. And 4.13. Dito, 4.13 din. Ayan, 4.13. So, I'm showing you na ang manual solution tsaka software solution is very similar. Okay, guys? So, that's it. Thank you for listening. Natapos natin ang computation ng center of mass. Ang next na sosolvin naman natin would be center of rigidity. Ang center of mass, ang kinocompute natin na center, yung center nitong lollipop, ano? Yan, yung bilog na yan. And when we're talking about center of rigidity, ang kinocompute naman natin na center dito, yung bumubuhat ng mass, which are the columns. Okay? And yung columns na yan, yan ang nagre-resist ng horizontal forces. Okay? So, kung kunin din natin yung centroid ng columns. But this time, ang i-consider natin sa columns would be the moment of inertia of the columns and not the area. Okay. Bakit sinabi ko na moment of inertia ng columns? So, ganito yon. Now, let's look at this floor plan. Okay? Copy ko lang yan. Eto. Kunya-kunya. Kunyari, ayan siya. Let's look at grid A. Ano? Let's say, ang dimension mo dito sa grid A, yung columns dyan would be 0.25 by 0.4. Ito, 0.25 by 0.4. Ayan. So, ang column mo magiging something like this. Diba? Yan. And then, let's say, eto naman, ganun din. 0.25 by 0.4. Diba? Ngayon, parehas ang area niyan, 0.25 times 0.4, which is 0.1 square meters, ano? Pero, kapag ang earthquake forces mo would be coming in this direction, something like this, pa ganyan. Okay? Ang moment of inertia niya for this earthquake, I would be equal to for this column, ano? Yan. For this column, your considering na ito yung ating earthquake, your I, moment of inertia I is equal to 0.25 multiplied by 0.4 raised to cube, okay, divided by 3, divided by 12. Okay? Pero, pag ang earthquake mo, ang palo ng earthquake mo is ganito na, transversal, ang moment of inertia mo would be equal to 0.4 multiplied by 0.25 cube divided by 12, which is essentially not the same. See? Ito 0.005. Doon sa earthquake na longitudinal ang direction 0.0013. Ibig sabihin, mas malakas yung ganitong layout, mas malakas yung column mo sa longitudinal earthquake. Okay? Ngayon, yung column mo, mahina siya sa transverse direction ng earthquake. Yan. So that's the reason why karamihan ng designs ko ngayon is square columns. So para parehas ang kanilang moment of inertia in both directions. Likewise, hindi nahirap yung foreman sa paglagay ng column ties. Yan. Okay guys? So thank you guys for listening.